Hi everyone, welcome to the IFID Kit of tutorial series for Arduino. Today we will learn lesson 4, Interactive Flowing LED Lights. First, let's look at the experimental phenomena. The LEDs will light up one by one, just like the water flows. When the last LED goes out, the flow of the lighting will turn backwards, thus circularly. If we turn the shaft of the potentiometer counterclockwise, the interval between the lighting of two LEDs will be prolonged. If we turn it clockwise, the interval will be shortened, which means the flow will speed up. Now let's take a look at the components we need for the experiment. Some jumper wires, a potentiometer of 50 kilo ohms, 8 resistors of 220 ohms, 8 LEDs, a breadboard, a USB cable, and a SunFounder Uno board. For the experiment, we need to know two components, potentiometer and LED. Potentiometers, sometimes called pots, are relatively simple devices. One terminal of the potentiometer is connected to a power source, and another is hooked up to a ground, a point with no voltage or resistance and which serves as a neutral reference point. The third terminal lies across a strip of resistive material. This resistive strip generally has a low resistance at one end, and its resistance gradually increases to a maximum resistance at the other end. The third terminal serves as the connection between the power source and ground, and usually is operated by the user through the use of a knob or lever. LED stands for light-emitting diode. A diode is a semiconductor that only allows passage of electrical current in one direction. An LED consists of two elements of processed material, P-type semiconductors and N-type semiconductors. These two elements are placed in direct contact, forming a region called the p-n junction. The main difference between an LED and other diodes is that an LED is specifically designed to produce photons and has a transparent package that allows visible light to pass through. When using an LED, you should connect a current-limiting resistor to protect the LED from overburning. In this experiment, the operating voltage of the LED is 1.5 volts to 2 volts, and the operating current is 10 amperes to 20 amperes. The power supply voltage of the SunFounder Uno board is 5 volts. The operating voltage of the LED we choose is 1.7 volts, and its operating current is 15 amperes. The current limiting resistance equals total voltage subtracted by LED voltage, then divided by current. In this case, that will be 5 minus 1.7 divided by 0.015. Thus, the current limiting resistance equals 220 ohms. Now let's take a look at the principle of the experiment. Actually, it is very simple. That is, to light the LEDs up in a specific order and then turn the shaft of the potentiometer to change the interval between the lighting of the LEDs. Knowing the principle, let's build the circuit. First, plug the 8 LEDs in a row and the potentiometer into the breadboard. Connect the cathode of LEDs to ground of the SunFounder Uno board. Connect 8 resistors to the anode of each LED respectively. And then connect them to pin 2 to pin 9 of the SunFounder Uno board. Next, connect the middle pin of the potentiometer to pin A0 of the SunFounder Uno R30 board, and the other two goes to ground and power supply. Now the circuit is completed. Next, open IDE. Type in your code, number of the LED you attach, create an array for LED pins, delay between changes, the current state of the LEDs is low level. Select the input pin for the potentiometer. Set all pins as output. Read the value from the potentiometer. If LED delay MS has passed since last change, turn off all the LEDs. Turn on the current LED. Increment by the direction value. Change direction if we reach the end. Compile the code and then connect the SunFounder Uno board to your computer and download the program. Now you can test the effect of the experiment. Turn the shaft of the potentiometer counterclockwise. You can see the interval between the lighting of two LEDs is prolonged, and the flow runs slower. Turn the shaft clockwise. The interval gets shorter and the flow runs faster. So that's all for our experiment. Thanks for watching.